Okay, so we're going to think about the equation that links wave speed to frequency and wavelength. And it's a fairly straightforward equation. Wave speed is equal to frequency multiplied by wavelength. Wave speed is frequency times wavelength. We use the symbol V, wave speed or velocity, F for frequency, and the one that's a bit odd is lambda. Think about length beginning with L, lambda begins with L, lambda for wavelength. In terms of units, that's meters per second, hertz or seconds to the power minus 1, and meters. And you can sort of see why it works, because if the wave is measured in meters and this is per second and we multiply it together, we get meters per second. Another way of thinking about it is the speed is dependent on the number of waves per second. If you've got lots of waves per second and a really big frequency, then you'll probably have a faster wave. If the waves are really long, you might get a faster wave. So wave speed is worked out by multiplying frequency and wavelength. All you need to remember when using this equation is to get the units right. Units, meters per second, meters there, and seconds to the power minus 1 or hertz there. And remember, not kilohertz, not megahertz. If you're working out using this equation, convert the frequency into hertz to start with. If you're the sort of person that likes triangles, then we've got a triangle for you here. The wave speed is equal to the frequency multiplied by the wavelength, V equals F times lambda. So frequency is wave speed divided by wavelength, and wavelength is speed divided by frequency. So let's have a go at a question. Often in this case, using this equation, we calculate things using the electromagnetic spectrum, because all electromagnetic radiation, all electromagnetic waves travel at the same speed. The speed is the speed of light, which we sometimes symbolise with c, and light travels at 300 million meters per second. That's the speed of electromagnetic waves in a vacuum. It's also the speed, therefore, for X-rays, ultraviolet, infrared, microwaves, and so on. They all travel at the same speed. Now, let's take my favourite radio station, Radio 4, which broadcasts at a frequency of 92 megahertz. 92 MHz. Okay. How long is one wave on the Radio 4 signal? What's the wavelength of a Radio 4 radio wave? It's got a wave speed of 300 million. It's got a frequency of 92 megahertz. What is the wavelength? Pause the video for a moment and see if you can work it out. Okay, so to work this one out, we're going to need to substitute into the equation. Wave speed is frequency multiplied by wavelength, and we want to work out the wavelength. So the wavelength is going to be the wave speed divided by the frequency. So that's 300 million meters a second divided by a frequency of 92. But we need to be careful because we've got 92 megahertz, 92 million hertz. So we need to put some zeros on there. We could put all that into our calculator, or we could do a bit of cancellation. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're going to end up with 300 divided by 92. And that's going to give us a value of 3.26 meters. Okay, so each Radio 4 radio wave is about 3¼ meters long, about half the length of this classroom. So there's only 2 of those waves going across this whole classroom. Okay, so that's the wave equation.